So hello everyone. Today we are going to start with weldment structures. There are two types of structures in weldments. First are that are made of standard structures such as square tube, round tube, C-channel, I-section beams. I'll show you some examples here. You can see here, this is I-section beam. Then we have angle sections here, C-channels, C-channels in this way also. Then square tubings, rectangular tubings and circular tubings. So whatever structural tubings are we are saying that are all hollow in structure and are having common thickness here. So we will start with all these structures. We are having some examples of structure to show you. What are weldment structures? Now you can see in these images. Suppose if you want to make this kind of structures, you can see here complete supports, stand plates, stairs and all the structure around is made of weldments. So this kind of structures we can make using weldments. So this is another example in which square tubes, round tubes, bases of sheet metal and other multiple things are used such as I-section beams and all to make a particular structure. Another example completely made of weldment structure only. The workers are working on the structures. These are I-section beams here, which are used in heavy structures. One more example of I-section beam here is this one. You can see here, these two sections, these two pieces of I-sections are connected to the middle piece here. That is horizontal in orientation and these are vertical in orientation. For the support, ribs are been added here that are called as gussets. We are going to see that also here. And then they are bolted on the structure. So this kind of structures we are going to make in weldments. So the reason we are pronouncing it as weldments, it is because we are going to weld one structure upon another. So we'll start with this sketch here. Either we can use 2D sketch or we can go for 3D sketches here. So I'll start with weldments. There itself you are having option of 3D sketch. Or else you can go by the traditional method using planes and then making sketches. That method also can be used to make sketches. Or else you can make sketches by using 3D sketch. You can make a hybrid sketch also using 2D as well as 3D sketch. It doesn't matter in which way you have made sketch. So we'll start with weldments by making a 3D sketch first. So we are going to make one table here. For that I'm going to select 3D sketch, and after selecting 3D sketch you can see the origin has been highlighted here in isometric view. So to start with I'm going to draw a rectangle which should be oriented at the top side here. So I'll select the rectangle. You have to keep in mind that we have not selected any plane here. We are directly selecting the command and starting with the center rectangle. But as I said, I want this orientation at the top, but it is coming at the front side. So to change the orientation in 3D sketch, we are having tab key on the keyboard. We just need to click on the tab key here. You can see the red color axis line will also change with the tab here. As I click on the tab, the direction of axis will change. So you can see the rectangle is coming at top side. After completing the rectangle and the orientation properly, we are going to give dimensions here. I'll say it as 1200 mm and this one as 600 mm. After putting up the dimension, it would have fully defined here. But still it is not defined. It is because we have drawn 3D sketch. We have not used plane here. To define the sketches, you have to define the orientation of the lines. And I need to add relation at which direction it is parallel to. So I'll add this direction as along X. You can see the UCS icon here. This line is coming parallel to X. That's why I'm going to add along X here. And this line is coming parallel to Y. So for that I'm going to add along Y. Sorry, it is coming along Z. So I'm going to add along Z here. And now you can see this sketch is completely defined. It means you have to add dimensions as well as you have to add the relations showing the axis at which direction the line is coming. And then only this sketch will be defined here. So after completing the rectangle, I am going to go for the support legs here for the table. For that I am going to draw vertical lines here along Y direction, you can see here. So I'll go for the line, select the line and drag the line in the vertical direction. It is seemed to be drawn in vertical line, but when you rotate the part, you can see this line is not coming parallel to Y axis. Instead, it is coming on the same plane as of these two lines. So what we need to do here is select the line and say it along Z. We need to select it along Y. I'll say it along Y. So it may over define here. I'll delete this relation along Z. Then it will automatically come to along Y. and now it is coming perpendicular to the sketch as a support leg here. We need to provide one dimension, so I'll say it as 620. In next line also I'm going to select the line. After drawing the line, we'll select the line again and say along Y, and then I'll put up the relation here as equal. After these two legs I'm going to go for the third. So now you can do one more thing here to change the direction. Instead of adding the relation later, we can tap the directions. You can see the red color axis will change the directions there, and now it is coming in Y direction. I'll click here. So instead of giving relation, you can go for this option also, that tap the button and you can change the direction along X, Y and Z. We have done this earlier also for the rectangle. Again the next line, it is by default coming in Y direction only. You can see the tracing line also there, blue color. We'll put up the relation equal for these lines also, both the lines. We will add one more support in between here. So from this midpoint to this midpoint, now my 3D sketch has been completed here. Still I want 4 more lines here. So I'll go for lines again, select the line, the other line, and you can see it is coming parallel to Z direction. So if I need parallel to Z direction, I'll select the line and add the relation as along Z. Same way, we'll go for this line here. It is coming parallel to along X. Next line parallel to Z, and another line, the last one, to complete this sketch. Now we need to provide the distances here for the lines. So I'll provide this distance as 160 mm. Similar, I'm going to add the distance here also, same as 160. I'll say this line parallel to the other line. Suppose it is over defining the sketch, then we'll delete these lines and make them one more time. So I'll draw this line again here and then say it parallel to the other line, and then the last line we have to provide here to complete this sketch. And now this sketch has been completed. We'll draw one more support in between this also. So I'll take this line command from midpoint to midpoint here. Our table structure has been completed. We are going to add structures here. Why 3D sketch is referred mostly? It is because if you use 3D sketch, you can see you don't need to make multiple planes here to complete this sketch. But in 2D sketch, you need multiple planes so as to complete this kind of complicated sketch there. So to avoid planes and to work in a single sketch, it is better to go with 3D sketch. Or else you can refer 2D sketch also, as we have used in part molding earlier. So I'll exit this sketch here to add structures now. Then we are going to select this weldment icon here. Click on this icon, and after that only we are going to start giving the structural members. It is compulsory to click on this icon as it will generate a cut list there. So if you select this icon, the parts we are going to make here will not be merged together and they will come as a separate bodies here. So after selecting weldments, I am going to go for the main command. After putting weldments, I am going to go for the main command, that is structural member. Select the option. You have to provide the standard first. So I am going to go with ISO. There are multiple standards such as NC inch, NC metric, JIS, GB, DIN, but we are going to go with ISO. Then for the type of section, we are going to select the types here. We have seen angle iron, C channel, pipe, tube, square tube, I section beam. So I'm going to select here C channel. Then we are going to go for the sizes here. I'll select 80 by 8. These sizes we can customize. We will see it later. Now in these groups, we have to select in such a order that multiple entities should be selected in one group. So it will make editing easy. As many groups as you are going to make here, editing will be different for the different groups. The important thing here is you can make groups of C channel. The condition is all the sizes should be equal and shapes should be same. If the size or cross-sectional shape of the structural member changes, then we are going to take another structural member instead of taking group. We cannot add group there. So it is compulsory for making groups that all the sections should have equal shape and size, then only we can go for the groups option here. First I am going to add this group here. I am going to select the lines in chain first, then this line as second, and this third, and the last one. But if I break this order, suppose I am going to delete this group and again go for the group, I am going to select this first line and the second line. But when I select the third line, it will not accept as a third line. As I have broken the chain here for the selections, it will not accept. So I have to go for new group so as to apply the structures here. So it is better to select the profiles in chain order here. I'll select this first line, second, third, and the last one. After selecting the lines, there are three corner treatments given here. First one is miter joint. You can see here all the corners are connected by 45 degrees joint here. I'll say it OK. And to understand, I'll hide this sketch. So now you can see the corners. These are the miter joints connected at 45 degrees. Suppose I change the type here. I'll say it end but one. You can see each cross section is connected in such a way that one is overlapping and the other side is underlapping. So this one is underlapping here, this bar, and it is overlapping at the other side. Same goes with this bar. It is underlapping here and overlapping here. So this was end but one. Suppose I change the type here and go for the third option, that is end but 2. It is similar to end but 1. One side will be overlapped and the other will be underlapped. Only the thing is these sides are flipped here. So in end but 1 this was underlapping and in end but 2 it is overlapping. Same with the other sides. But suppose I want these channels to be underlapping here from both the ends, from the upper end also and from lower end also. It is already underlapped from the upper side. Then we should go for individual corner treatment. I'll show you. Suppose I want this bar to be underlapped from both the ends, so I have to go for treatment on this point here. And for this bar, I'm going to go for treatment on this corner point. So I'll select the C channel, say edit feature, select the individual point. The difference is here if you select the corner treatment, it will be applied for all four corners. But if you go for individual points, then it will apply only for the particular corner only. So I'll select that point, and instead of end but 2, I'll give its opposite side end but 1. Say it OK. And for this point also, end but 1, say it OK. Now after selecting OK, you can see here both these C channels are underlapping on both the ends here. Here also you can see, and these both horizontal channels are overlapping on both the ends. So this way you can individually change the corner treatment. Suppose I want to add this as a C channel only, then I'll go for new group and select this as a C channel. You have to keep in mind all the groups will have same shape and size. We cannot change the size for this particular group here. If you want to change the size, you have to go for new structural member. I'll select the orientation. I want to orient it at the top side. Now it is coming at the bottom side. So to go for top side, you can see the profile, 2D sketch profile here. And that profile is having multiple points. So if I click on this corner point, this whole profile will be shifted at upper sides on this point. So for that, one option is given here, that is locate profile. I'll select this locate profile. After selection, it will work for once only. So again, if I want to change the profile, again I have to click on locate profile. So after selecting locate profile, I'll go for this point, and you can see this C channel is being shifted at the upper side here. If I want this C channel to be shifted at both the ends at midpoint, then I'll go for this midpoint option. And now you can see C channel is coming. And now you can see C channel is coming from the mid orientation here. Same if I want this C channel to be coming at this corner here. So I'll again say locate profile and click on the corner point. So in this way, by using these multiple points, you can shift the profile as the way you want. Say it OK. Now we'll see the locate profile for this outer side also here. Select edit feature, and now for group 1 I want to locate the profiles here. Suppose I want this C channel to be coming in such a way that it should be oriented half at upper side, half at lower side. And again I'll say locate profile. For the point selection, I am going to give this midpoint here. So this profile is coming half at upper side, half at lower side. Say it OK here. We will show the sketch so as to understand the references. You can see here this section is coming equally divided on both the sides. Now if I want this thickness to come outside, then again I'll edit the feature here, go for locate profile, and you can see all the star points you can utilize here to locate the profile as the way you want. So I'll select this point here. Now the thickness is coming at outside. Suppose I want this point and the profile to be located upwards. So I'll say locate profile again and say this point. This profile will be located upper side from all the ends as a single group. This was locate profile option. You can utilize it here. If you want to add some star marks here, you can go to this sketch and add the marks or star points as you require. Suppose I want to locate one more point by customization. I said OK. I'll expand this C channel model tree, and in sketch I'll say it edit sketch, and here you can see the C channel profile. I'll add one more point here with alignment to this end at the center. I'll define it properly by giving the vertical relation and horizontal relation with this horizontal point. Say exit sketch. Now we will say edit feature again. Go for locate profile, and you can see that we have added one more point here. This is the customized point. If I select this point will be shifted on the intersection of the sketch at this pink color section. So I'll select this point here, and now this complete profile is located for C channel. All the four channels have been located at the same point as it was taken completely in one group. This channel is not been located as it was in another group. If you want to edit that channel also, say group 2 and then add the required point. I'll say this point, say it OK. So this was corner treatments and locate profile option. Now we'll do one thing, we are going to change the structure here. So I'll say edit feature again, and instead of C channel I am going to go for rectangular tubings here. You can see after applying tubing also, even then these channels are not been updated yet. It is because till the time you don't apply this size, it will not be shown here or it will not be displayed here. So I'll say one size here, say it 50, 30, 2.6. So this is length, width and thickness. So we have applied a group here, and the same profile will be applied for the other group also with same sizes. So I'll say it OK again, and now you can see this rectangular tubings. Even after applying the rectangular tubing, the corner treatments are same as they were for C channel. Now we'll go for edit feature again, and now the orientation for the rectangular tubing is coming in such a way that it is vertically oriented. Suppose if I want this rectangular tubing to be oriented horizontally, then we are going to change the angle here. For that, select the angle option. So in the same feature there is option for angle. I'll select the angle and say it 90 degrees. So this orientation is now horizontal for rectangular tubing. You can see here, but only group 1 is been edited here. To edit group 2, I'll select the group 2 option and then change the angle for group 2 also. I'll say it 90 degrees, same as earlier. And now all the orientations for rectangular tubing are coming in horizontal way. You can see here. If we again go for locate profile, there are certain points given by which we can locate the profile. So for this group 2 profile, I'll select this point. Complete tubing is coming at lower side, you can see. Again, I want to orient it from mid section, so I'll select locate profile and say midpoint here. This point will be shifted on the sketch here. So this was locate profile. We can also go for angle iron section. Select the required size, and now all the profiles are coming as an angle iron here. I'll locate the profile so as to bring it in proper alignment. I'll edit the group 1. One more option is also given, that is mirror profile. Select the mirror profile option, and you can see the angle profile has been oriented horizontally here. If I off this option, the initial position was this one, but if I on this option again, it will go for horizontal axis and the orientation will be changed. You need to observe here. I'll select mirror profile and it is flipping horizontally. Again off this option and say on again. Next we are going to go for vertical axis. Now it is flipping vertically here, you can see. So this is mirror profile option. By this option also you can orient the profiles as you require. I'll change it for group 2 also. Select the group 2 and again go for mirror profile. Say locate and change the location. Again say OK. So now angle frame has been applied here. You can see the orientations. I'll put on the sketch again. This was structural member tab. We are going to continue with the table in next lecture, and we are going to cover the other commands which are left here. If I continue in the same lecture, it would be a lengthy lecture. So this was session 25 for weldments. The first session for weldments. The further remaining command for the weldments will be continued in upcoming lecture or session 26. So please follow the playlist so as to completely understand the weldments here. Till then, thank you.